Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain Chemistry Standard Level Paper 2, May 2023, Time Zone 1. If you find this video is helpful, don't forget to subscribe and let's get started. Number 1, this question is about acid-base properties. Did you use the ionic equation, including state symbols for the reaction of hydrogen chloride gas with water? So hydrogen chloride, that would be in aqueous, react with H2O liquid, produce Cl minus in aqueous state as well, and H3O plus in aqueous state. Okay, HCl acts as an acid because it donates protons to water, and water is acting as a base because it accepts protons from HCl. Calculate the pH of 0.5 molar hydrochloric acid. So pH is negative log concentration, so you will get 0.3. Explain why a solution of ethanoic acid has a higher pH than hydrochloric acid of the same concentration. Ethanoic acid is a weak acid that dissociates partially, while HCl is a strong acid that fully dissociate. Okay, thus pH of ethanoic acid is higher or bigger, is higher than the pH of hydrochloric acid. Okay, so even though it has the same concentrations, but the ions that will be produced will be different. The ions of Cl as an acid, the ions when HCl dissociates will be more compared to the ethanoic acid, because HCl, when it dissociates, it's gonna be fully dissociated. A pH probe can be used to distinguish between the acid in part C. Identify another simple instrumental method that could be used in a school laboratory to distinguish between the two acids. You can use conductivity. The conductivity of a solution of a strong acid is higher than a weak acid because strong acid is fully dissociated, so it produces a higher concentration of ions even though they both have the same concentrations. Outline how the instrumental method identified in part D distinguishes between the acid in part C. As I said, this instrument will have higher conductivity on HCl due to higher amount of ions. So strong acid, when it dissociates, it is fully dissociated. So even though it has the same concentration, but the ions that will be produced from the hydrochloric acid as a strong acid will be more compared to ethanoic acid as a weak acid that dissociate partially. The periodic table is a useful tool in explaining trends of chemical behavior. Annotate and label the ground state orbital diagram of boron. So boron is 5. So 1s2, 2s2, 2p, 1. And there is He as a short notation. So 2 electron will be cut because He has 2 electrons. So left 2s2. So 2s and then 2p. So it's 2 and then 1. So for one orbital can be only 2 spin, and the third orbital, so the spin should be pointing it up. So if it's 4, so 1 pointing up as well, and then the fourth, it would be pair and then it's pointing it down. Sketch the shape of the occupied orbital identified in part A and 1. So we have S and then P. So S orbital will be like this, it's a circle, and then P will be like this. IB except you can write X or Y or the other one. Explain the decrease in first ionization energy from Li to Cs group 1. So as you go down group, okay, Li to Cs, number of electron increases, causing more electron shells, making valence electron as the electron on the outermost shell further from the nucleus, because the atomic radius is also getting increased. So thus the radius gets larger, less attractive forces, easier to remove electron. State the electron domain geometry of the ammonia molecule. So this is ammonia, and it has 1 pair of electron. It has 4 domain geometry, so the name would be tetrahedral. Okay, be careful. If its molecular shape name is not tetrahedral because it has 1 lone pair. So molecular shape and geometry are both different things. Deduce the Lewis electron dot structure of ammonia and sketch each 3D molecular shape. So it will be 1 pair, 1 electron from H, 1 electron from N, and we have 1 lone pair. And for the 3D, we'll do like this, and like this, and this, and a lone pair. Okay, so this is a line in a plane of paper, and this is dash which projects away from you or from the observer, and then this dark which projects towards the observer or you. Explain with reference to the forces between molecules why ammonia has a higher boiling point than phosphine. So ammonia, the Lewis structure of ammonia, it will be like this, and phosphine coming from group 5 also will be like this. So both of them has a lone pair, so both have a lone pair, thus have dipole attraction. However, you can see here N and H is a hydrogen bond. However, ammonia has hydrogen bonding, which is NH, makes it higher boiling point. Okay, but pH doesn't have hydrogen bond. Outline what is meant by dynamic equilibrium. Dynamic equilibrium means the rate of the forward reaction is equal or equals to the rate of the reverse reaction in a closed system. To use Kc expression for the reaction in part D1. So Kc will be the concentration of product to the power of its coefficient and divided by concentration of reactant, and for H2 the coefficient is 3. The Haber process requires a catalyst. State how a catalyst functions. Catalyst will alternate pathway and lowers activation energy. All right. Next question. Sketch a Maxwell-Boltzmann distribution curve showing the activation energy with and without catalyst. Okay, so D will be, okay, so it will not be like this. Okay, so start from here. Let me okay, so this part, all right, there are more particles here that has lower kinetic energy compared to here, lower number of particles that has kinetic energy, and this therefore with catalyst, and this one without catalyst. Okay, so next question. Suggest how the progress of the reaction could be monitored. It can be any change in volume, or maybe change in pressure, or maybe change in temperature. Outline the meaning of homologous series. Homologous series is a compound that have the same general formula, or compound that have the same functional group. State the preferred IUPAC name for the following compound. If we draw here, this will be CH3, this will be C and has one H, this will be CH2, and this will be CH3. This will be CH2, and this will be C and with one H, and this will be CH3, and this will be CH3 as well. And as you can see, this C attached chlorine attached to this C, and the Cl should be at the lowest number, so we will count from the right side, because if from the left it will be number 3. So it's 2-chloro, and we have 4C, so the name would be 2-chlorobutane. And for this one, Cl attached to the number 1, C number 1, and there is alkyl in C number 2, and we have only 3C as the longest change. So we start with 1-chloro and 2-methyl propane. So it should be chloro because C alphabetically start with C, and then methyl M. Butene can be but2-ene can be polymerized. Draw a section of the resulting polymer showing 2 repeating unit. So butene, C, H double bond CH, and CH3. Okay, when we draw, the double bond will be single bond if it's a polymer for the repeating unit. So we start with C. So it has first the bond here for the represent repeating unit, and we have C. Okay, this one will be H, and this will be CH3. Okay, so we start CH3, CH, and we continue C, H, and CH3. Okay, so this one also will be repeated again, C, H, and CH3, and C, H, CH3. And don't forget to write N. Okay, redox reaction can be used to produce electricity. State the oxidation state of sulfur in copper to sulfate. Okay, copper to Cu2 plus. So if you combine these two, it will be cancel out. That will be CuSO4, and O, the charge is -2. It will be -8. Cu2 plus, so plus 2 to be equal to 0. S will be plus 6. A voltaic cell was constructed using a copper 2 sulfate copper half cell and a zinc sulfate zinc half cell. Outline why electrons flow from zinc to copper when these half cells are connected with a wire. If we look at the data booklet 25, okay, it's zinc, it's more reactive than Cu. So the reason why electrons flow from zinc to copper, because zinc is more reactive, thus it is easily to lose electron. Okay, so if losing the electron, it means oxidation. So zinc lose the electron because it's more reactive, experience oxidation, and Cu will experience reduction, gaining electron. And for oxidation, and ox, so this will be an anode, cathode. So Cu experience reduction will be at the cathode. Okay, so anode oxidation will be for Zn, oxidation losing the electron, so the electron will be right here, and Cu gaining electron, Cus, aqueous, S, and aqueous. Double salts are substances with 2 cations and 1 anion. 1 cations and another one anion. A hydrate sulfate containing 2 cations has this percentage composition. So oxygen will be the left from 100. Okay, it's a percentage. So calculate the percentage of oxygen. So it will be 100 minus all of this data. 7.09 plus 511 plus 16.22 plus 14.91, that would be 56.67%. Determine the empirical formula of the double salt. So to find the empirical formula, we need to find the mole for each of them. So we start with N, 7.09, the mass of N, divided by its relative atomic mass. Carbon is 14.01, produce 0.506, and for H will be 5.11 divided by 1.01, producing 5.06, and for S will be 16.22 divided by 32.07 will be 0.506, and for CO 14.91 divided by 58.93 produce 0.253, and for oxygen 56.67 divided by 16 produce 3.54. You cannot write N 0.506, H 5.06 for the empirical formula. So you can divide it by the smallest number, which is 0.253. So 0.506 divided by 253, 5.06 divided by 0.253. The same goes for this one and then this one as well. So you will get N2H20 S2CO. It's 1O14. So the empirical formula will be N2H20 S2CO NO14. Okay, so that will be the answer. And the molar mass of the empirical formula is the same as the molar mass of the formula unit. So deduce the formula unit of the hydrated double salt. Okay, so from N2H20 S2CO O14. The question said the molar mass of the empirical formula is the same as the molar mass of the formula unit. So you can see we have NHSCO and NO, and it's hydrated. So hydrated, it means contain NH2O. The double salt means contains two different type of ions. So what kind of ions that we can see here? If it's N and H, maybe you can think of NH4 plus and SO. You can think as SO4 2 minus. In the previous question it said cations and anions anyway, and we have CO. Okay, and because the molar mass of the empirical formula is the same as the molar mass of the formula unit, so we don't simplify. Therefore NH4 plus will be 2 because we have N2. SO4 2 minus will be also 2 because we have S2. So after calculating how many N and 2, and then H will be 8, S is 2, and then O will be 8. So there are more 12 H hydrogen and 6 oxygen left. Therefore, we can say N is 6. So when you write the formula unit of hydrated double salt, that would be CO, and there is no more charge, 6H2O. One 1.2 gram of the double salt was dissolved in water, and an excess of aqueous barium chloride was added. Formulate an ionic equation including state symbol for the reaction of barium ion, it's group 2, with sulfate ion, SO4 2 minus, producing BaSO4, cancel out, that will be solid. Calculate the mass of barium sulfate precipitate. Use your answer to part A3 and section 6. Okay, so to find the mass, you need to find the mass of the barium sulfate. So there is sulfate here, so we need to calculate the mole of sulfate ion and the double salt. So that will be mass of double salt and divided by molar mass of the double salt as well. So the mass of double salt is 1.2 gram based on this information data, and then divided by, for molar mass of N2H20S2CO14 is 395.29 gram per mole. So you will get 3.04 times 10 to the power negative 3. But be careful, because it's SO4, 2 minus sulfate. In the double salt, we have 2 sulfate. Okay, so you need to multiply 2, which is 6.08 times 10 to the power negative 3 mole SO4. So to find mass of BaSO4, N times Mr, we got N, which is 6.08 times 10 to the power negative 3, and the mole will be the same, 6.08 times 10 to the power negative 3, because SO4 here is only 1, and that will be equal with 6.08 times 10 to the power negative 3 times Mr of BaSO4, which is 233.4, and you will get 1.42 gram. Okay, for the next question, determine the standard enthalpy reaction in kilojoule per mole for the oxidation of SO2 to SO3. To find delta H, it will be delta H of product minus reactant. Okay, so product here is SO3, so negative 395.8 minus 296.8, then you will get negative 99 kilojoule per mole. Formulate equations showing how SO2 and SO3 lead to acid deposition. So SO2 as an aqueous react with H2O liquid, producing H2SO3 aqueous. Okay, so this will be equilibrium because H2SO3 is a weak acid, but for SO3 aqueous will react with, when it reacts with water, it will produce sulfuric acid, and it's not equilibrium because sulfuric acid is a strong acid. Explain the polarity of the SO bond. Use section 8 of the data booklet. So if we check the section 8 right here, okay, section 8 is about the electronegativity. So electronegativity of O and S. O is more electronegative compared to S. Therefore, the polarity S and O is more electronegative, so it's partially negative, and this one partially positive. So oxygen is partially negative, and S or sulfur is partially positive. Okay, next, the combustions of 0.1 moles of sulfur was demonstrated in the school laboratory using the following apparatus and fume cupboard. Calculate the enthalpy of combustions. So to calculate the enthalpy is mc delta T divided by N. It will be 50.9 times 4.18 times 35 minus 20 divided by 0.1. You will get negative -31.350 joule per mole, or -31.4 kilojoule per mole. Don't forget the negative here because the temperature increases. Suggest the major source of systematic error in this experiment and an improvement to reduce this error. Source of systematic error, usually when calculating or doing experiment related to the enthalpy change, very common, it's about heat loss to the surrounding. Okay, and what about improvement? You can choose any. You can put a lid on a beaker. You can also use insulator for the apparatus, and then you can also use bomb calorimeter, is a specific apparatus that used to calculate enthalpy change. Okay, calculate the percentage uncertainty in the temperature change to two significant figure. For the initial temperature is 20, uncertainties is 0.5, and for the final temperature is 35, it's 0.5 degrees Celsius. So to calculate percentage uncertainty, if adding, we need to add the uncertainties as well. So that will be 0.5 plus 0.5 divided by measured value, which is 15, the difference in temperature, times 100. You will get 6.7%. Okay, suggest one way of reducing the percentage uncertainties in this experiment. Uncertainties caused by instrumentation error. So to reduce the error by using, or when you use the instrument, you can use more precise balance, or you can use more precise thermometer. Okay, calculate the overall percentage error of this experiment. Use part B1 and section 13 of the data booklet. So section 13, this the data of enthalpy of combustion. The question is about sulfur. Okay, so sulfur. So the experimental value for sulfur is -297 kilojoule per mole. That's why when I do the calculation here, I change it into the kilojoule per mole, because from the data booklet, the unit is kilojoule per mole. Okay, so to calculate the percentage error, it's gonna be absolute experimental value minus accepted value and divided by absolute also accepted value. So if we plot, that would be 297, as we see on the data booklet, minus 31.4 and divided by 297 times 100, you will get 89.4%. It's very, very big. Okay, so that's it for the chemistry paper 2 standard level May 2023 time zone 1. If you find this video is helpful, don't forget to subscribe, and bye.